Good afternoon, lovely ladies, gentlemen, creatures of the Middle East. I don't know where you're coming from. But anyways, in this video I'm going to be talking about arithmetic sequences and partial sums. An arithmetic sequence is basically something where you add or subtract to get to the next number. So like in this sequence, 7 to 11 we do plus 4, 11 to 15 is plus 4, 15 to 19 is plus 4, so I'm adding 4 each time. So this is an arithmetic sequence where the difference is 4. This is a part of our formula. Our formula for an arithmetic sequence is a sub n equals dn plus c. C is some number, d is our difference, so like in this case, d is 4 because that's the difference from one number to the next. Our first term, if we want to actually find the entire equation, our first term is 7. A sub 1 is 7, so I know when n is 1, a sub 1 is 7. So I can say that 7 equals 4 is my difference times 1 plus c. So solve for c, and I will find that c is 3 when you subtract 4 over. So the equation for this whole problem right here would actually be a sub n equals 4n plus 3. Okay, we're going to do some more of these so that you get extra practice there. Buenísimo! Okay, one type of example you will see in this section is it gives you the first term, it tells you the difference, and it wants you to write the first 4 terms. Well, we know our first term is going to be negative 3. If we know our difference is 4 and it's positive, then I'm just going to add 4 each time. So negative 3 plus 4 is 1, plus 4 is 5, plus 4 is 9. Hey, there's 4 terms. All right, another example, same type of problem. It gives you your first term, tells you the difference. So our first term is negative 8, wants to write the first 4 terms. I'm adding 3 each time, so negative 5, negative 2, and 1. There are 4 terms. They're going up by my difference of 3 each time. Good to go. Another type of example may just ask you to find the common difference. All this is, common difference just means d. So find the d, find the common difference. From 3 to negative 2, it goes down 5. Negative 2 to negative 7 also goes down 5. Negative 7 to negative 12 also goes down 5. So there is our common difference. It is negative 5. We go down 5 each time, so that is our difference. Like magic. You may also be asked to write the formula for a sub n. So we have our sequence. We have 12, 17, 22, 27. I notice that this is going up by 5 each time. And as we just talked about, there's our difference of 5. I have my first term is 12, so a sub 1 is 12. And I know just kind of the common formula for an arithmetic sequence is a sub n equals dn plus c. I already have this part of it. The only thing I need to find is c. However, I know when I have a sub 1 and n is 1, right, when 1 is n, so I can just plug in n for 1, that this is supposed to be 12. So I have 12 equals 5 times 1 plus c. So then c must be 7. So that helps me write my equation, which is a sub n equals 5n plus 7. And there it is. Another problem you may see is it may ask for a specific term based on 2 terms that were given to you. Well, if I have my first term and I have my second term, I notice that the difference between these 2 is 4. So there's my d. d is 4. And I know the formula a sub n equals dn plus c. I can use a sub 1 or a sub 2, it doesn't matter. Whatever you want to plug in, just make sure you apply the correct n with it. So if I have a sub 1, if I use 6, my difference is 4, n is 1 plus c, so c must be 2. When you subtract 4 to the other side, it's 4 times 1 is 4, minus 6 minus 4 is 2. So my formula that I know is a sub n equals 4n plus 2. To find my 49th term, all I'm going to do is plug in 49 for n. So 4 times 49 plus 2. 4 times 49 is 196 plus 2 is 198. Another concept that I'm going to cover, this last concept, when I have like 3 more examples and I'll be done with this video, is the sum. This is the sum of an arithmetic sequence. Okay. We're going to talk about another one in the next video called a geometric, but this is the formula for an arithmetic sequence. So this is to find the sum of numbers. So if we have like a giant set of numbers so that we don't have to do 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way up to like 100 or something, we can use this formula, where n is the number of terms A sub 1 is your first term, A sub n is your last term. And then if we use this fancy-dancy formula, we will find the sum of all of our parts in a shorter amount of time. So for instance, say if we want to find the numbers, the sum of the numbers from 1 to 100. I can say that the sum of the numbers, well, there are 100 numbers total, right? Because if I have 1, 2, 3, 4, 5, I'm just counting them. So there are 100 terms, so I can say 100 divided by 2. My first term is 1. My last term is 100. So I can just plug this into your calculator, whatever you want to do, and you will come out that the answer is 50/50. Kind of like 20/20, but not as cute as Barbara Walters. Here's another example. This time it's given to us in summation notation, where we want to find the sum of all the numbers from 26 to 75 for this rule. So I know my first term is going to be when I plug in 26, so you can say this is a sub 26 if you want to. But if I put in 26, 2 times 26 is 52. My last term, a sub 75, is when I put in 75, so 2 times 75 is 150. So then I can use my formula, n over 2 times a sub 1 plus a sub n. In this case, n is 70, well, and this will be our a sub 75. But think about it, from 26 to 75, there are only 50 numbers. The way that we can do this is we can say that 75 minus 26 is 49, but when you count, your 1 has to start with 26. So like 26 is my first, 27 is 2, 28 is 3, 29 is 4, 30 is 5. So what we have to do is we have to add one more to get this 26 involved in the whole sequence. So now what I can do is say 50 divided by 2 times, what do we have? 52 plus 150, which is, again, Barbara Walters, but not as cute. Alright, this is the last example I'm going to do with you guys in this video. So again, it wants to find the sum, so I'm going to use this formula, n over 2 times a sub 1 plus a sub n. Okay. In this case, my first term is going to be when I have 13, so a sub 13 is when I plug in 13. 13 squared is 169, plus 3 is 172. And I need to find my last term, which is 50. When I plug in 50 squared plus 3, 50 squared is 2500, plus 3 is 2503. Okay, n, to find n, I'm going to take 50 minus 13. This is 37. Don't forget to add 1, so n is 38. So when I plug in my numbers, I'm going to have 38 divided by 2 times 172 plus 2503. And this is going to come out to be 5825, 50825. Hopefully this video was helpful. I appreciate you guys watching as always, and have a wonderful rest of your evening. Pack Daddy out!